ਵਿਦਿਆਰਥੀਓ, ਜੇ ਕੋਈ ਐਲੀਮੈਂਟ ਅਜਿਹਾ ਹੈ ਕਿ ਜਿਸ ਦਾ ਆਲਟਰਨੇਟਿਵ ਲੱਭਣਾ ਮੁਸ਼ਕਲ ਹੈ ਤਾਂ ਉਹ ਹੈ ਐਲੂਮੀਨੀਅਮ। ਭਾਵੇਂ ਐਂਸ਼ੀਐਂਟ ਪਰਸ਼ੀਅਨ ਪੋਟਰਸ ਨੇ ਐਲੂਮੀਨੀਅਮ ਨੂੰ ਆਪਣੀ ਪੋਟਰੀ ਨੂੰ ਮਜ਼ਬੂਤ ਕਰਨ ਲਈ ਆਪਣੀ ਕਲੇ ਵਿੱਚ ਐਡ ਕੀਤਾ, ਪਰ ਐਲੂਮੀਨੀਅਮ ਧਾਤ ਦੀ ਖੋਜ 1825 ਤੱਕ ਨਹੀਂ ਸੀ ਹੋਈ। ਇੱਥੋਂ ਤੱਕ ਕਿ ਇਸ ਦੀ ਖੋਜ ਤੋਂ ਬਾਅਦ ਵੀ ਇਹ ਗੁੰਮਨਾਮੀ ਦੇ ਹਨੇਰੇ 'ਚ ਹੀ ਰਿਹਾ। ਕਿਸੇ ਸਮੇਂ ਤੇ ਕੈਮਿਸਟ ਇਸ ਦੇ ਸਿਰਫ ਕੁਝ ਮਿਲੀਗ੍ਰਾਮਸ ਹੀ ਵਰਤਦੇ ਸਨ ਅਤੇ ਇਹ ਇੰਨਾ ਦੁਰਲਭ ਸੀ ਕਿ ਇਸ ਨੂੰ ਸੋਨੇ ਅਤੇ ਚਾਂਦੀ ਤੋਂ ਬਾਅਦ ਬੇਸ਼ਕੀਮਤੀ ਧਾਤ ਵਜੋਂ ਜਾਣਿਆ ਜਾਂਦਾ ਸੀ। ਇੱਥੋਂ ਤੱਕ ਕਿ 1884 ਵਿੱਚ ਅਮਰੀਕਾ ਦੀ ਕੁੱਲ ਐਲੂਮੀਨੀਅਮ ਪ੍ਰੋਡਕਸ਼ਨ ਸਿਰਫ 125 ਪਾਉਂਡਸ ਸੀ। ਅੱਜ ਦੇ ਇਸ ਪਾਠ ਵਿੱਚ ਅੱਗੇ ਵਧਣ ਤੋਂ ਪਹਿਲਾਂ ਆਓ ਅੱਜ ਦੇ ਵਿਸ਼ੇ ਦੇ ਲਰਨਿੰਗ ਆਬਜੈਕਟਿਵਸ ਜਾਣ ਲਈਏ।
On completion of this topic, learners will be able to discuss occurrence of aluminium, discuss extraction of aluminium from its ore, discuss refining of aluminium, list and discuss uses of aluminium, discuss recycling of aluminium.
ਵਿਦਿਆਰਥੀਓ, ਪੀਰੀਓਡਿਕ ਟੇਬਲ ਤੇ ਦੂਜੇ ਐਲੀਮੈਂਟਸ ਵਾਂਗ ਐਲੂਮੀਨੀਅਮ ਨੈਚੁਰਲੀ ਅਕਰ ਹੁੰਦਾ ਹੈ। All elements are arranged in the periodic table by their atomic number. The number below aluminium's symbol is its atomic number. Thus, atomic number of aluminium is 13. So, an aluminium atom has 13 protons and 13 electrons. Aluminium belongs to group 13, known as the boron family. This group includes boron, gallium, indium, and thallium. These elements possessing similar properties are located above and below aluminium in the periodic table as shown on the screen. The symbol for aluminium is capital A with small l. Aluminium's atomic weight is 26.98 atomic mass units. Students, today we will learn about the occurrence and extraction of aluminium. Let us first discuss about the minerals containing aluminium. Let us have a look at an animation before going further.
Minerals containing aluminium. Aluminium isn't found in nature as a pure element. It exhibits relatively high chemical reactivity. Aluminium occurs widely as a constituent of rocks and soils. Aluminium is the most abundant metal in the earth crust. It is most abundant element by weight after oxygen and silicon. The main ores of aluminium are bauxite, Al2O3 2H2O, which is hydrated aluminium oxide, is the principal mineral used in the preparation of aluminium on an industrial scale. Bauxite is often accompanied by iron oxides. Cryolite, Na3AlF6, feldspar, KAlSi3O8, mica, KAlSi2O10OH twice. In India, aluminium occurs mostly in the form of mica. The ores of mica are located in the states of Bihar, Tamil Nadu, Madhya Pradesh, Jammu and Kashmir. A large quantity of mica is exported every year to different countries. आओ एक एनीमेशन ਦੀ ਸਹਾਇਤਾ ਨਾਲ ਵੇਖੀਏ ਕਿ ਬੌਕਸਾਈਟ ਦੀ ਮਾਈਨਿੰਗ ਕਿਸ ਤਰ੍ਹਾਂ ਕੀਤੀ ਜਾਂਦੀ ਹੈ। Bauxite mining. Deposits of bauxite occur near the surface of earth. Bauxite is mined mechanically by removing the upper layer of soil, and then the mineral is transported to aluminium smelting plant where the pure metal is extracted. Bauxite mining contributes to environmental degradation, destruction of vegetation, and impoverishment of the soil. Nowadays, with the view of minimizing damage to the environment, the topsoil is collected together with the vegetation and stored until the given deposit is depleted. When the excavation is refilled with soil, new vegetation is planted. Moreover, the recycling of aluminium parts reduces the demand for bauxite and helps to contribute to environmental protection.
Students, let us now discuss about the extraction of aluminium. Aluminium is normally extracted from bauxite ore, that is Al2O3 2H2O. The process of extraction involves two steps: purification of bauxite, electrolysis of alumina. Let us first learn about the purification of bauxite. The purification of bauxite ore can be done by leaching of alumina from bauxite. The principal ore of aluminium, bauxite, usually contains silicon dioxide, iron oxides FeO, Fe2O3 and titanium oxide as impurities. Concentration of ore is carried out by digesting the powdered ore with a concentrated 45% hot concentrated solution of sodium hydroxide in the presence of water at 473 to 523 Kelvin and 35 to 36 bar pressure to form aqueous sodium aluminate as shown on the screen. In this process, alumina dissolves forming sodium aluminate. This process is also known as Beer's process. In this process, silicon dioxide is also leached as sodium silicate, leaving behind the impurities. The impurities of iron oxides, that is FeO, Fe2O3 and titanium oxide, are insoluble and are removed by filtration. The solution containing sodium aluminate is neutralized by passing carbon dioxide gas and hydrated aluminium oxide is precipitated. At this stage, the solution is seeded with freshly prepared samples of hydrated aluminium oxide, which induces the precipitation. Sodium silicate formed above remains in the solution and hydrated alumina is removed by filtration and is dried. Hydrated alumina is heated to 1473 Kelvin to get pure alumina as shown on the screen. Now let us learn about types of bauxite ore. Bauxite ore is of two types: red bauxite, white bauxite. If the main impurities are oxides of iron, it is called red bauxite. White bauxite, on the other hand, if the main impurities are due to oxides of silicon, the bauxite is called white bauxite. Beer's process, which we have discussed now, is used for the purification of red bauxite. White bauxite is purified by Serpeck's process. Let us discuss it now. Serpeck's process for extraction of aluminium. In this process, the powdered ore is mixed with coke and heated to 2073 Kelvin in an atmosphere of nitrogen. Alumina changes to aluminium nitride while silica gets reduced to silicon, which being volatile is removed as vapors. Let us have a look at the equation on the screen. Aluminium oxide reacts with nitrogen in the presence of carbon at 2073 Kelvin to form aluminium nitride and carbon monoxide. Silica present in the ore reacts with carbon at 2073 Kelvin to form silicon and carbon monoxide. Further, the equations on the screen show that aluminium nitride obtained in this equation is hydrolyzed with water to get the precipitate of aluminium hydroxide and ammonia. The precipitate is separated, dried and ignited to get pure alumina. आओ हुन पढ़िए extracting aluminium from its purified ore. Aluminium cannot be produced by the reduction of carbon as in case of iron because aluminium is more reactive than carbon. That is why free aluminium is prepared by electrolysis. संबंधित प्रक्रिया है कि electrolysis of fused alumina जिसਨੂੰ Hall Heroult process भी कहा जाता है. As electrolysis could be carried out only in liquid, so aluminium oxide has to be liquefied first. However, the problem is the melting point of aluminium oxide. It is as high as 2050 degrees Celsius. It is very expensive to carry out industrial process at such high temperature as high energy inputs are needed. Thus, a special refractory material is needed. That is why prior to melting, aluminium oxide is mixed with another aluminium mineral, cryolite. The melting point of the mixture is only half that of pure aluminium oxide. आओ इस प्रक्रिया ਨੂੰ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝਣ ਲਈ ਇੱਕ ਐਨੀਮੇਸ਼ਨ ਵੇਖੀਏ.
Here, the purified alumina, which is dissolved in molten cryolite or calcium fluoride, is electrolyzed in an iron tank lined inside with carbon. The molten cryolite, that is Na3AlF6, decreases the melting point to about 1173 Kelvin and also increases the electrical conductivity. Here, the carbon lining acts as cathode. We can also see a number of carbon rods which are dipped in the fused electrolyte. The carbon rods act as anode. The electrolyte is covered with a layer of powdered coke. The overall reaction is as shown on the screen. Alumina reacts with carbon to form aluminium and carbon dioxide. That is 2Al2O3 plus 3 carbon gives 4 aluminium plus 3 carbon dioxide. During electrolysis, the following reactions occur. At cathode, Al3 positive in molten state accepts 3 electrons to form aluminium in liquid state. At anode, carbon in solid state reacts with oxide ion in molten state to form carbon monoxide gas and 2 electrons are released. Carbon in solid state can also react with 2 O2 negative ions in molten state to form carbon dioxide and 4 electrons are released. Thus, aluminium liberated at the cathode gets collected at the bottom of the tank, from where it is removed periodically. The oxygen evolved at the anode combines with the carbon of the anode to produce carbon monoxide. Carbon monoxide either burns to carbon dioxide or escapes out. Because of this reaction occurring at carbon anodes, these need to be replaced periodically.
आओ हुण तीजे प्रोसैस रिफाइनिंग ऑफ एल्यूमीनियम ते नज़र मारिए। एल्यूमिना दे इलैक्ट्रोलिसिस राਹੀਂ प्राप्त कीती एल्यूमीनियम मैटल 99% प्योर होंदी है, पर इस विच आयरन, सिलिकॉन ਅਤੇ एल्यूमिना ਦੀਆਂ impurities ਹੁੰਦੀਆਂ ਹਨ, ਪਰ ਇਸ ਨੂੰ ਹੂਪਸ ਇਲੈਕਟ੍ਰੋਲਿਟਿਕ ਮੈਥਡ ਨਾਲ ਰਿਫਾਈਨ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ। The process is carried out in an iron tank lined inside with carbon. It has 3 layers of fused mass. The lower layer consists of an alloy of impure aluminium with copper. This layer serves as anode. The middle layer consists of a solution of cryolite and barium fluoride. The upper layer consists of pure aluminium and serves as cathode. These 3 layers are separated from each other due to difference in specific gravity. During electrolysis, Al3 positive ions from middle layer migrate to upper layer where they are reduced to aluminium by gaining 3 electrons. Equal numbers of Al3 positive ions are produced in the lower layer. These ions migrate to the middle layer. Pure aluminium is tapped off from time to time. Hoops method gives 99.99% pure aluminium. Let us have a look at the electrochemical changes taking place during the process. Cryolite decomposes to give sodium fluoride and aluminium fluoride. This aluminium fluoride furnishes aluminium ions and fluoride ions. Now have a look at the reactions occurring at cathode and anode. At anode, impure metallic aluminium furnishes tri-positive aluminium ion by losing 3 electrons, whereas at cathode, tri-positive aluminium ion accepts 3 electrons to form pure metallic aluminium. Thus, the reaction comes out to be tri-positive aluminium ions reacts with impure metallic aluminium to form pure metallic aluminium and tri-positive aluminium ions. Let us now discuss about the uses of aluminium. Versatility ਦੇ ਕਾਰਨ aluminium ਦੇ ਬਹੁਤ ਸਾਰੇ ਉਪਯੋਗ ਹਨ। ਦਰਅਸਲ ਸਟੀਲ ਤੋਂ ਬਾਅਦ ਇਹ ਦੂਜੇ ਨੰਬਰ ਤੇ ਵਰਤੀ ਜਾਣ ਵਾਲੀ ਧਾਤ ਹੈ। The automotive industry is aluminium's fastest growing market. Making car parts from aluminium, everything from wheel rims to cylinder heads, pistons and radiators, makes a car lighter, reducing fuel consumption and pollution levels. Aluminium is an attractive metal and often requires no finish, but it can be polished, painted and electroplated. For example, beer and soda makers use a printing process to affix their labels on aluminium cans. We can list some of the uses as: aluminium is used for making electrical transmission cables as it is a good conductor of electricity. Aluminium powder is used as a reducing agent in thermite welding. In the form of finely divided powder, it is used in anti-rust paints and lacquers. Aluminium foils are used up for wrapping fruitstuffs, chocolates, etc. It is used to remove dissolved oxygen during the extraction of certain metals. It is used in making household utensils. Aluminium, being highly reactive, is used in the extraction of chromium and manganese from their oxides. It is also used in making certain alloys. These alloys are extensively used for household purposes. Some of the common alloys of aluminium are magnesium, consisting of aluminium and magnesium, and alnico, consisting of aluminium, iron, nickel and cobalt. Now it's time to discuss recycling aluminium. हैरान करन वाली गल ਇਹ ਹੈ ਕਿ ਹੁਣ ਤੱਕ ਮਾਈਨ ਕੀਤਾ ਗਿਆ aluminium ਅੱਜ ਵੀ ਵਰਤੋਂ ਵਿੱਚ ਆ ਰਿਹਾ ਹੈ। ਇਹ ਇਸ ਕਰਕੇ ਹੈ ਕਿਉਂਕਿ ਇਸ ਨੂੰ ਬਾਰ-ਬਾਰ ਰੀਸਾਈਕਲ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ। ਐਲੂਮੀਨੀਅਮ ਉਦੋਂ ਤੋਂ ਰੀਸਾਈਕਲ ਕੀਤਾ ਜਾ ਰਿਹਾ ਹੈ ਜਦੋਂ ਤੋਂ ਪਹਿਲੀ ਵਾਰ ਇਸ ਦਾ ਕਮਰਸ਼ੀਅਲੀ ਉਤਪਾਦਨ ਸ਼ੁਰੂ ਹੋਇਆ ਸੀ। ਅੱਜ ਪੂਰੇ ਵਿਸ਼ਵ ਵਿੱਚ ਇਸ ਦੀ ਕੰਜ਼ੰਪਸ਼ਨ ਦਾ 1/3 ਹਿੱਸਾ ਰੀਸਾਈਕਲਡ ਐਲੂਮੀਨੀਅਮ ਹੀ ਹੈ। ਇਸ ਤਰ੍ਹਾਂ ਅਸੀਂ ਕਹਿ ਸਕਦੇ ਹਾਂ ਕਿ ਰੀਸਾਈਕਲਿੰਗ ਆਫ ਐਲੂਮੀਨੀਅਮ ਸਨਅਤ ਦਾ ਜ਼ਰੂਰੀ ਹਿੱਸਾ ਹੈ ਅਤੇ ਇਹ ਇਕਨੋਮਿਕ, ਟੈਕਨੀਕਲ ਅਤੇ ਇਕੋਲੋਜੀਕਲ ਤੌਰ 'ਤੇ ਬਹੁਤ ਲਾਹੇਵੰਦ ਹੈ। Most aluminium that gets recycled comes from one or all of these three sources: used beverage cans, parts from old automobiles, and scrap collected during the manufacture of aluminium products. Aluminium recycling is a closed loop process, which means the new product made after the recycling process is the same as the one before. There are 6 steps to closed loop can recycling. Old aluminium cans are taken to an aluminium reclamation plant. The cans are shredded into small pieces. The pieces are fed into a melting furnace. The molten aluminium cools and hardens into rectangular ingots. The ingots are formed into thin sheets of aluminium. The thin sheets are used to make new cans. Let us have a look at an animation related to it.
Recycling of aluminium. Nowadays, the yearly global production of aluminium cans reaches 178 billion pieces. 22 billion pieces of these are used in Europe. Therefore, to avoid depletion of raw materials, it is important to process used containers for further use, that is, recycle them rather than bury them in waste dumps. Used aluminium cans are collected in special containers like glass, plastic, and paper. They are then transported to processing plants. The cans are then cut into pieces. Any pieces of iron and steel are then removed using powerful magnets. Sand is separated by shaking the mixtures and washed with water, which is then evaporated at a high temperature. The purified scrap metal is then remelted and processed into new cans or articles. As the reclaimed material retains the properties of the original material, so aluminium can be recycled repeatedly. Do you know? 1 ton aluminium scrap 4 ton bauxite ਅਤੇ 700 ਕਿਲੋ crude oil ਨੂੰ ਸੇਵ ਕਰਨ ਵਿੱਚ ਸਹਾਇਕ ਹੈ। ਇਸ ਦਾ ਇੱਕ ਹੋਰ ਲਾਭ ਇਹ ਹੈ ਕਿ ਇਹ ਵੇਸਟ ਦੀ ਮਾਤਰਾ ਨੂੰ ਰਿਡਿਊਸ ਕਰਦਾ ਹੈ।
The future of aluminium. Primary production of aluminium requires tremendous energy. It also produces greenhouse gases that affect global warming. According to the International Aluminium Institute, manufacturing new stocks of aluminium releases 1% of the global human-induced greenhouse gas emissions. A top industry priority is to decrease these emissions through reduction measures, increased recycling of aluminium. In fact, using lightweight aluminium components in vehicles like aircraft, watercraft and trains is one of the most significant advances in automotive design and manufacturing. Every kilogram of heavier material that is replaced by aluminium results in the elimination of 22 kilograms of carbon dioxide over the lifetime of the vehicle. Another promising application is the use of aluminium in fuel cell powered cars. Researchers in USA recently discovered that aluminium could be used to produce hydrogen fuel efficiently. The process begins with aluminium pellets, which are mixed into liquid gallium to produce liquid aluminium gallium. When water is added, the aluminium reacts with the oxygen to form a gel. Hydrogen gas, which can be collected and used to power a fuel cell, is also produced. Innovations such as these will increase the demand for aluminium. Even though the metal is relatively young, it is one of the most important in the history of human civilization. When the archaeologists and anthropologists of tomorrow reflect on the society of the 19th, 20th and 21st centuries, they could very likely label it the Aluminium Age, placing it next to the Stone, Bronze and Iron Ages as one of the most significant periods in human cultural development. ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਵਿਸ਼ੇ ਦੇ ਅੰਤ ਤੇ ਆ ਗਏ ਹਾਂ। ਕੁਝ ਪ੍ਰਸ਼ਨ ਪੁੱਛ ਕੇ ਇਹ ਪਤਾ ਕਰਦੇ ਹਾਂ ਕਿ ਤੁਸੀਂ ਅੱਜ ਦੇ ਪਾਠ ਵਿੱਚੋਂ ਕੀ ਸਿੱਖਿਆ ਹੈ।
Here is my first question. Match the answers shown on the left hand side with those on the right hand side. What does A stand for in the diagram? The correct answer is A stands for anode. Next is, which reaction takes place at B in the figure? The answer is 2O2 negative gives O2 plus 4 electrons in this reaction. Next question is, what does C represent in the diagram? The answer is molten aluminium oxide and cryolite. Next question. What is shown in the layer D in the figure? The correct answer is D represents liquid aluminium. Next is, what does E represent in the diagram? Answer is E represents the cathode. And the last question is, which reaction takes place at F in the figure? Answer is this reaction, Al3 positive plus 3 electrons give aluminium, takes place at F. Now try to answer these questions. Question: what happens at cathode during Hall-Héroult process? Answer: aluminium ions from aluminium oxide Al2O3 accept 3 electrons from the cathode and get reduced to aluminium atom, which form the aluminium metal. Question: what happens at anode during Hall-Héroult process? Answer: oxide ions from aluminium oxide Al2O3 lose their 2 electrons to form oxygen atom. 2 oxygen atoms combine to form oxygen gas molecule, and carbon combines with oxygen to form carbon dioxide. Question: why is cryolite added to alumina Al2O3? Answer: cryolite is added as it decreases the melting point of alumina Al2O3 to about 1173 Kelvin and increases the electrical conductivity.
Excellent. Well done students. ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦਾ ਇਹ ਪਾਠ ਕਾਫੀ ਦਿਲਚਸਪ ਲੱਗਿਆ ਹੋਵੇਗਾ। ਅੱਜ ਦੇ ਇਸ ਵਿਸ਼ੇ ਨੂੰ ਧਿਆਨ ਨਾਲ ਸਮਝਣ ਲਈ ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ। ਅਗਲੀ ਵਾਰ ਇੱਕ ਹੋਰ ਵਿਸ਼ੇ ਨਾਲ ਫਿਰ ਮਿਲਾਂਗੇ।